I have explained a brief requirement document, an instance of requirement document for case study, and you know that in this case we had a bank branch that have its own ATM system. In this ATM system, each customer has just one account, and at the time just one transaction could be run in this system. And in this ATM system we have a screen to show messages, keypad, and cash dispenser, and deposit slot with the meaning that introduced to you in previous lecture. And then in the later lecture we have introduced you a technique to extract classes from requirement document, which named by lexical analyzing. In lexical analyzing technique, we should review the requirement document and mark nouns and noun phrases, and make a list of nouns and noun phrases to determine classes, the primary classes, such as this. At this stage, we reviewed the nouns and noun phrases to determine which nouns could be classes, and which of them could be attributes of some other classes. As you know, we decide that some of these nouns, such as account, such as withdrawal, such as deposit, such as customer, and transaction, bank database, screen, all of these nouns, keypad, are our primary classes in this case study. But some other nouns or noun phrases, such as PIN, such as account number, such as some other balance, some other terms such as balance, all of these are attributes of some other classes. So we go ahead with this notion. We have summarized the list of all classes that could be extracted by lexical analyzing, by reading the requirement document and making a list of nouns and noun phrases. By continuing this technique, we continue to do more analysis over the requirement document to determine attributes of the candidate's primary classes and methods for these classes. As you know, we show a class in UML standard in unified modeling language by a three-part rectangle. The first compartment, as I told before, is used for the name of the class. The second compartment is used for the list of attributes, and this third one is used for a list of methods of the corresponding class. And then we use a class diagram in UML standard to show the relationship between classes. At the previous lecture, we told about class diagrams enough for you, and we will continue to this discussion at this lecture and other lectures. Let me see your messages, please. Okay, okay. No problem. Okay. For example, the relationship between the ATM class and the withdrawal class is discussed in previous lecture. We showed the relationship between classes by a solid line, and we have a variety of association types, such as simple associations and such as composition relationship is a relationship or part of a relationship. There are several relationship types, and we will introduce them in details in future. At this case, there is a simple association between the withdrawal and ATM class, and this association is named by executes, which means that the ATM class can execute one transaction of type withdrawal over the bank database and return an output to the screen for the customer, and probably give amount of money cash to the customer by cash dispenser. And we have talked about the multiplicity that are written at the over the ends of this association line, as you see in this figure. We complete this class diagram for the ATM case study in previous lecture, and for this completing, we have drawn 4 other classes which make together the ATM machine. As you know, the ATM machine has a screen, has a cash dispenser, has a keypad, and has a deposit slot. So the relationship between the ATM and these classes are in type of composition relationship, as written in the caption of this figure. In composition relationship, we say that a keypad is part of an ATM, or a screen is part of an ATM. And on the other hand, we can say that an ATM has a keypad, an ATM has a screen, and ATM has a cash dispenser. So we name this relationship has a relationship. So this is has a relationship, and so on for other relationships in this figure. This figure also relate the part of relationship. The part of relationship is equivalent to has a relationship. These two are the same, because when we relate, when we tell from this end, we define the relationship from this end, we start from this end, we say that deposit slot is a part of an ATM, is part of an ATM. But when we define from this end, we say that the ATM has a deposit slot. So the has a and part of is equivalence. Okay. We continue to this subject at previous lecture, and we reach to this diagram as intermediate diagram. We will complete it more in next lecture, in next section or next chapter, this class diagram. In this class diagram, as you see, we have an ATM machine which consists of these 4 parts, and this ATM system, as I told before, can execute some withdrawal transactions. For executing these transactions, it is needed to have a relationship with bank database object, and bank database should read a specific account related to the withdrawal, and then the bank database should reduce the amount of this account by the value which received from withdrawal transaction, and overwrite the balance account into the bank database. And on the other hand, we can see you have seen this relationship between ATM and bank database, and ATM for authenticating its users should have a contact with bank database, and check if a user account such as you know from previous lecture, an account includes both the PIN number and account number. So the ATM should receive an account number and a PIN, personal identification number, and send both of them to the bank database to validate, to authenticate if there is an account with this account number and PIN number. If it's true, the ATM let the user to use from the services of the ATM. For example, the ATM prompt a main menu for the user if the user authenticated successfully. And at the end of previous lecture, you've seen that we have provided some needed methods for our classes and some attributes for our classes. This figure lists all needed attributes for each class. For example, for withdrawal class, there is needed to have an account number and amount of money to be withdrawn. Or in deposit transaction, it's also needed to have a specific or a special account number and amount of money to be deposit at the account. Or for example, each account is specified by 3 attributes such as account number, PIN, and balance, and so on. These materials are introduced to you by video materials that I have sent to you. I hope you have seen these video materials, and you know that in this figure we see our classes with their attributes. The attributes of each class is defined in corresponding compartment of the class notation, as you know. So by this definition, we know that, for example, an account class has an account number of type integer. PIN is integer again, but the available balance and total balance are double objects. Okay, and if we go ahead to next slide, we should determine the methods of these classes. The methods of these classes should be extracted again by lexical analyzing and extracting the verb phrases or verbs of a requirement document, and when we detect the source of verbs or the subject of those verbs, we can find that the verb is a method of which class. For example, by reading the requirement document, we can find that an ATM should execute financial transaction. This is a verb phrase. This verb phrase implies that the class ATM should execute the withdrawal, the deposit, the balance inquiry transaction, as you know. So the ATM class should have some objects of type withdrawal and some types such as deposit and balance inquiry, and this class should have an execute method to call the execution method of mentioned classes, mentioned objects. And for some other classes such as screen, you can see that the screen for the screen class there is a verbal phrase in requirement document, such as this verbal phrase displays a message to the user. So the screen class should have a method named display. Or for other classes such as bank database, we use bank database to authenticate a user. That authenticates a user is a verb phrase. Retrieves an account balance should be done by bank database. So this could be a method of bank database. Credits a deposit also is a method, could be a method of bank database. So we can use this lexical analyzing technique to determine the methods of our classes. As you can see in this figure, we see all methods of all classes. For example, in bank database, you can see that the authenticate user could be a method of this class. Get available balance, get total balance, credit and debit are two methods that are used for make a deposit or make a withdrawal transaction. Execute a deposit and execute a withdrawal transaction. And for other classes such as screen, we can see the display message method for screen, get input method for keypad, execute method for deposit, execute method for withdrawal, execute method for balance inquiry. You know that these three classes are three types of transaction in this case study, and all of them have an execute method, but the execution of each type of these transactions are different. You know that the execution of deposit is different with the execution of withdrawal transaction. So we can use the polymorphism technique to in this case study in next lecture, and we can use inheritance again to have a different organization of these classes in next lecture. But now we define three isolate classes in this case study, but in next chapter we can refactor our design, refactor our code by some other possibilities of object-oriented techniques. I have received some messages. Okay, there is no problem. No voice. Can you hear me? Miss Sarah wrote that no voice. Can you hear me? Yes. Can you understand my talks? Yes, yes. If you can't understand my talks, you can see the video materials. I have sent you enough video materials for this lecture. The voice is low. Probably this is for your net. Because of your net, I have no problem with my connection. Okay, okay. Let's me go ahead. In this figure for the bank database, we have done for the design activity by defining the attributes, by defining the parameters of each method. For example, for authenticating a user, it is needed to have an account number and a PIN number of each user, and the return type of authenticator user should be of type Boolean, true or false. Each user could be authenticated if she or he has provided a correct account number and a correct PIN number. It should be authenticated, but otherwise it should be prohibited from entering to the system or using the ATM system. And for get available balance, it should be provided an account number to the bank database object. The bank database object can read the specified account and read the balance or amount attribute of that account and return to the user by writing a message on the screen. Or for other methods, this is trivial. For credit or deposit, we again need to have two parameters for both of them. The first parameter should define the account number that we want to credit it, and the second parameter defines the amount money to be added or subtracted from the balance of the related account. Okay. And in this figure, we have seen the complete definition of class account. For class account, we have 4 attributes, which include account number, PIN, available balance, and total balance. And we can define 5 or more methods, such as validate PIN, the validate PIN returns a Boolean value. This could be used for authentication a user. This method receives a PIN parameter and check if the PIN that it received is the same with the PIN which is registered in the database. If both of them are the same, it will return a true value, but otherwise it will return a false value. And get available balance is a getter method to return the available balance attribute, the value of the available balance attribute. And this is the same for get total balance. In this getter method, we should return this attribute, the total balance attribute. And the credit method should be added the value amount in its parameter to the available and total balance. And in debit method, we should subtract the total and available balance by the value of this parameter, but this amount parameters. Okay, so we have a clear definition of account class, and we should do the same work for all other classes and make a brief definition of all the classes in the ATM system. So you can see in next slide the definition of all classes as you see. This is the end of the first part of the ATM case study. I make a good summarization about the part 1, but in the next part we will talk about some other aspects of object orientation, analysis, and design. Let me. Okay. In part 2, the sound is cut. Can you hear me? Yes. No problem. Okay. In this, the objectives of this chapter or of part 2 of this lecture, of this case study, is to incorporate inheritance into the design of the ATM case study, incorporate polymorphism possibility into the design of the ATM, and fully implement in Java the UML-based object-oriented design of the ATM software. So at the end of this lecture, we will see a fully implementation of this case study. So I think it's a very good case study which you will experience, in which you'll experience all the process of generating a software. We started by requirement gathering, providing a requirement document. We have an analyzing of the requirement document to determining the primary classes by doing lexical analysis, to finding nouns and noun phrases to define primary classes, and we have done some other activities such as analyzing the verbs and verb phrases to determine, to extract the related methods of each class from the requirement document, and we have done a refinement over the definition of classes by defining a clear definition of each class by detecting the needed methods and needed parameters and needed attributes for each class. At this time, we want to complete the final class diagram as we have seen in previous lecture, and make a primary implementation. After we have a primary, we see a primary implementation, we try to incorporate inheritance and polymorphism possibility into this case study. Let me see your messages. Yes, Miss Sarah, go ahead, please. No problem. I think Miss Sarah has no sound. Okay. Yes, no problem. Okay. Let me go ahead. Okay, as you see, this is the contents. This is a brief agenda of this chapter, of this lecture. After we have an introduction starting with classes that we have made in previous lecture, and we start the implementation of primary classes, and then we make some inheritance relationship, some inheritance classes should be defined for this case study, and we use polymorphism. At the end of this chapter, we will provide a complete implementation of ATM case study in Java language. This is a brief definition of various sections of this chapter. Let me to skip from this slide and go to the next slide. In this slide, we talk about the visibility. As you know, in object-oriented, an attribute or a method could be a public or private or protected. As you know, when we define an attribute in a class as a private attribute, you cannot have an access to this attribute from outside the class. For example, in other classes, you cannot see the private attribute of other classes or private methods of other classes. But when we define an attribute or a method as a public attribute or method, you can see from outside of the class those attribute and method. So we have some marks or markers in UML notation named as visibility marker. In UML notation, we define the private accessibility by minus, and we define the public accessibility by class. And furthermore, we have uh, another accessibility modifier which named protected. The protected attribute could be seen in friend classes or in child classes or subclasses. In subclasses, you can see the attribute of the class and the attributes of the parents or the attributes of friend classes. In C++, there is a possibility that you can define two classes as friend of each other, and when you define the friendly relationships between two classes, in each class you can see the protected attributes or methods from each other classes. I got about five messages. Let me. Okay. Yes, yes. The solution of the problem is done through the Java language. Yes, on the computer. No problem. Yes. The voice is discreet. I think your net has a problem. Miss Sarah, I think your net has a problem because your friends have no problem with my voice. Okay, the sound is clear for other friends. Okay, as I told you, access modifier determines the visibility or accessibility of an object, attributes, and methods to other objects. Uh, Before we begin implementing our design, we must consider which attributes or methods of our classes should be public and which of them should be private, as you know. In UML notation, as I told, we define the public by plus sign and private by minus sign. Attributes normally should be uh, private. It's common, it's usual to define attributes as private attributes, but usually methods are public. It's possible to have a private methods, but it's rare. And normally we make methods as public methods. In special cases, you can have private methods again. Methods that are called utility methods only by other methods of the class normally should be private. The utility methods is defined for doing some computation in class, and they are only used. They are only can be used by local methods of that class. So you could define utility methods as private methods. Let me go ahead. Okay, as I told before, the visibility marker in excuse me, let me excuse me. As I told you before, the visibility marker in UML language is defined by sign, by plus and minus sign, and the protected is defined by the sharp sign, which is not written in this slide. Okay, let's go to the next slide. At this figure, you can see the previous definition of all classes of the ATM case study, in which the main difference between this figure and the previous one in previous lecture is that in this figure we have defined the previous accessibility modifiers in front of our attributes and methods. As you know, as you see, for example, in account class, all methods is defined as public methods, and all attributes are defined as private attributes. And it's simple for you, and no problem. Let's go ahead. The another concept in object-oriented design and in making or defining the relationship between classes is navigability. The class diagram, for example, in figure 32, this is figure 32. In this class diagram, you can see some arrowheads that define the navigability of our relationships. This means that the ATM can use these classes, and for example, in this relationship by this arrowhead, we can determine that the bank database can use the account object, or withdrawal object can use the bank database. Excuse me. So the navigability, the class diagram in figure 30.2 further refines the relationships among classes in the ATM system by adding navigability arrows to the association lines, which you have seen in previous chapter. The navigability arrows represented as arrows with stick arrowhead in the class diagram indicates the direction which an association can be traversed. When we want to traverse the relationship between classes, we can use the direction of this arrowhead to define the story of using these classes, executing the methods of these classes. So it is very important, and we can use these directions to defining the priority of classes in implementation phase, because as I told you, when we have a direction from withdrawal to a screen, from withdrawal to the cash dispenser, from withdrawal to keypad, they are means that in withdrawal object we should define some objects of type screen, cash dispenser, and keypad within the withdrawal class. Okay, so the withdrawal class should have objects of these types inside it. Okay, and the withdrawal should call some methods of these objects, the objects of these types. So the direction of execution is started from withdrawal and continue to the destination objects. Okay. Programmers use navigability arrows to determine which objects need interfaces, need references to other objects. As I told, the withdrawal object should have references to these three classes when we want to implement withdrawal. So it's more easier to make implementation of a screen class, cache dispenser, and keypad before making an implementation for withdrawal. Because when we want to implement withdrawal in your IDE, your implementation environment, when you want to define for example an object of type screen, and you know that you have not made any implementation of a screen before, so the compiler makes some error for you, and then numerous errors of compiler could be confusing for you. So it's easier to make an implementation for these classes before implementing the withdrawal class, because when you make a screen class, cache dispenser class, and keypad class initially, then you go ahead to making withdrawal class. In implementing withdrawal class, now you can you can define objects of these types simply, because these classes are defined before, and compiler returns no errors for you, and it could be more pleasable. Okay, so we can use these navigability signs, these directions, to determine which classes should be implemented before other classes. It's necessary to say that, for example, the class, the keypad class, which has no any dependency to other classes, could be implemented at first. This is the same for deposit slot, because the deposit slot has no any dependency to other classes, but the ATM class should be implemented after all other dependent classes. Okay, we cannot make an implementation for ATM class until the classes deposit slot, keypad, cache dispenser, screen, withdrawal, and bank database is created. When all of these classes are created, we can make an implementation for ATM class. Okay, because the class has some dependencies to these other classes. So the ATM class in this class diagram is the last class that we should implement. The first class could be classes such as deposit slot, keypad, account, screen, and cache dispenser, because these classes are free from any dependency to each other classes. They are independent of other classes. but the class withdrawal, for example, is dependent to these classes which has a directed arrow or a directed association with them. Okay, so if we should make an schedule for implementing these classes, I prefer to make an account class, deposit slot, keypad, cash dispenser, and screen at first stage, and next, in the next stage, we should implement classes which all dependent classes are made before. For example, next we can make we can make bank database class. In the second stage, we just make bank database class because the other class, means account class, is created before, and there is no other classes that which bank database is dependent to it. So we can, in the next stage, in the second stage, we just make bank database. After bank database, when we investigate this class diagram, we can determine that just two classes such as ATM and withdrawal class are not implemented. When we focus on other relationships such as this execute, we can find that an ATM class could not be implemented before withdrawal class. But the withdrawal class could be implemented because all other classes which withdrawal is dependent on them are created before. Bank database, screen, cash dispenser, and keypad are created before. So we can make an implementation for withdrawal class. When the withdrawal class be ready, now we can implement the final class, means the ATM class. Okay. Let me see your messages. Okay. Just Miss Sarah has problem with my sound. In this lecture, again, I forgot to take a record for you. There is no problem because you have another video from Professor Farzad Sanati. There's no problem for this lecture, but in the next lectures, please remember me to take a record for you. Until now, we have no any record for you, but in next lecture, probably it is needed. Lectures, probably it's needed to take a record, to have a record. Please remember me. I forgot it again. Inshallah. Let me go ahead with the text of this slides. Associations that have navigability arrows at both ends or have none at all indicate bidirectional navigability. It's possible to have bidirectional navigability in other scenarios, in other case studies, but in this case study, as you saw, we have directional navigability in this class diagram, and there is no need for bidirectional relationships in this case study. Directional navigability, navigation can proceed in either directions across the association. It's trivial for you. So if you have no question, we go ahead with this, with the implementation activity. Okay. Let me to see how we can implement the design classes. At this stage, we start the implementing primary classes that we found in previous slides, implementing the ATM system from its UML design. We are now ready to begin implementing the ATM system. To do this, we define a brief approach to convert classes in UML diagram into Java code. It's a very simple approach because we have a clear definition of our classes in these two figures. In figure 30.2, we have a class diagram which tell us which classes should be implemented first, and furthermore introduce the order of implementation of each class in this class diagram. And by this figure we can make a brief implementation for each class. At this phase we just make a skeleton code, because we could not define the body of methods automatically. By this approach, we just define the skeleton, the definition of our classes. The body of our methods should be defined later by the developers, by the programmer. So the code will represent the skeleton of the system, because we just define our classes and not the body of all methods. To make this implementation, we use 4 guidelines for each class. First of all, we use the name located at the first compartment to declare the class as a public class with an empty or no argument constructor. For each class, we make a default constructor. The default constructor is a constructor which has no parameter. Okay, no argument. As you know, the constructor is a method with the name of the class. The name of the constructors is the same as the name of the class, and the constructors executes automatically when we make an instance of that class, when we make an object of that class. Okay, so in this figure you can see a withdrawal class which have one constructor, the default constructor, the constructor with no argument. In object-oriented languages such as C++, such as C#, such as Java, as I told, you can note that the constructors could be defined by methods with the same name as the class has. The class name is withdrawal. The constructor should be named by withdrawal. And the other point of this constructor is that the constructor has no return type. As you see in this case, this constructor is defined with no return value. But in other methods, in your classes, you should define the return value. If you have no any return value, you should define a void method. But for constructor, this is not true. Okay, so in the first step of this guideline, we make a simple class as a public class with the name of the class. The name of our first class is withdrawal, and we make a default constructor. The default constructor, as I told you, is a constructor that has no argument. In step 2, we should use the attributes located in the second compartment to declare the instance variables of the class. For example, if I go back to the definitions of withdrawal class, you have seen that the withdrawal class has two attributes. The account number attribute is a private attribute of type integer, and the amount attribute is a private attribute also, and it's a double attribute. Okay, so by doing this step, by doing the step 2 of this guideline, we should define two attributes for this class. We should add two attributes for this class, and we have this implementation. These two attributes is defined, is added to this code. So in the second step, we should define the attributes of the class according to our definition, according to the notation, the UML definition of the class withdrawal. Okay. In the third step, we should use associations described in the class to references to other classes. For example, for excuse me, 5 and this association, the direction of this association can refer to ATM class. So the withdrawal class just refer to a screen, refer to cache dispenser, the associations that describe references to other class. This means that this relationship is our focus in this case, in this stage. Okay, for these associations, we should make some instances within the withdrawal class. For example, we should make an object of time screen, an object of time, a variable of type cache dispenser, a variable of type keypad, and a variable for bank database, an instance of bank database. To doing this step for withdrawal class, we should refer to figure 30.5. Figure 30.5 is here. As you see, we should make 4 instances of these 4 types of classes. We should make an object of type screen, an object of type keypad, an object of type cash dispenser, an object of type bank database. Why? Because as I saw before in class diagram, we have a directed relationship between withdrawal class and these other classes. When we have a directed association, we are the withdrawal class is dependent of those classes. The withdrawal class, to execute a withdrawal transaction, needs to use some services of other classes, such as display message bus by a screen object, such as give money to the customer by cash dispenser, such as receiving the amount of cash is needed by customer from keypad. So to do its responsibility, a withdrawal class, to do its responsibility, it needs to use the services of other these classes, as we have seen in design phase, and make a directed association between this class and other classes. So this is translated completely to the code in this step. We use these references, these directed associations, to make an instance of each dependent classes. Okay. And at the fourth or final step, we should use operations located in the third compartment of figure 30.1. You have seen figure 30.1. For withdrawal, we just have an execute method, which is a public method. So by the fourth step, we should use the third compartment of the definition of class to implement the execute method, to add the execute method, to declare the shell of the method. We just, in this step, we just define the shell of the method, not the body of the method. The body of the method should be implemented by the programmer. It could not be done automatically. Okay. If we have not yet specified a return type for an operation, we declare the method with return type void. Refer to the class diagram of previous chapter. No problem. Don't important. Okay. By doing the last step of those 4 guidelines, we adding the executed method to the withdrawal class. So you saw these 4 guidelines, and you saw how we can apply these guidelines for a class withdrawal. You should done these steps for all classes in your class diagram. in this lecture, we just apply these guidelines for withdraw. But you should do these steps for all other classes. When all other classes are implemented by these 4 guidelines, you have a completed skeleton code for your case study. Okay. The remaining part of the implementation will be the completing the body of methods. And as you know, the body of methods could be simple, because each method have a small responsibility, and there is no more complexity in implementing these methods, because each method has a small responsibility and it is defined in the design phase and in requirement document. So the other activity is to complete these steps for all other classes. Let me see the time. The time is over, and it's enough for this lecture. In the next lecture, in the next session, we will complete this chapter and complete this case study. And you can find out some design techniques for case study ATM. And in next weeks, after 2 weeks, we have holiday in Iran. We start to some advanced concepts, such as other techniques to finding classes, such as object-oriented principles, means abstraction, means encapsulation, modularity, and the hierarchy, relationships between classes. And after that, we focus on some design patterns, creation of pattern and behavioral pattern, and we will go ahead through our course plan. If you have any question, please ask your questions, and if not, let me to finish the lecture. Please download the lecture